class, we got you. Wherever you want it from, we got what you need. Today online class.
Good day, viewers all over the world. You are welcome to Toydell online class. Today we want to look at circle geometry. Circle geometry. Of course, from the word circle, we all know a circle. A circle has a center. So a line drawn from the center of the circle to any part of the circumference is called radius. So if a line is drawn from the center of the circle to any part of the circumference, it is called radius. And of course, we can have another line from this center back to this place. It's also called radius. Then when we have two radii is called diameter. That is, say diameter is equal to 2 radius. So radius is equal to diameter all over 2. We all know this relationship. We know the circumference of a circle can be equal to 2 pi r. And we know the area of a circle. Area of a circle to be equal to pi r squared. So we know some of this property. I just want to do a kind of revision. So before we can go into circle geometry proper, we should know all this relationship. We should also know that the diameter divides the circle into 2 equal halves. So diameter is a line that touches the circumference of a circle at 2 points and passes through the center. That is diameter. But we can also have another line that touches the circumference of a circle at 2 points, but does not pass through the center. And that line is called chord. This one is diameter. So this second line is called chord. A chord is a diameter, but a diameter is not a chord. Let's note. A chord touches the circumference of a circle at 2 points. A diameter touches the circumference of a circle at 2 points. But a chord does not pass through the center, while a diameter passes through the center. So we must note that every chord is a diameter, but a diameter is not a chord. So another property, of course, the diameter divides the circle into 2 equal halves to semicircle. But this chord now divides the circumference of a circle into 2 to minor arc and major arc. If this is the chord, the circumference from here to here, this smaller circumference is called minor arc. Then the bigger one is called major arc. Okay. Then this same chord divides the circle itself into minor segments and major segments. Of course, if I decide to shade all this place now, all this shaded portion is called segment. This is referred to as major segment. The bigger one is major segment. When we divide the circle itself into 2, we have something of this nature. We have something like this, and the small one. So this is called the minor segment. This is called the major segment. So we should know the difference. The chord divides the circle into minor segment and major segment. The same chord divides the circumference, just circumference. The circumference is just the line, that circular line, into minor. This is minor. This is called the minor arc. Then the bigger one, without what is inside, is called the major arc. So that is that about that. So this is just simple introduction about some of the properties of a circle. So under circle geometry, we'll be taking theorems on how to solve problem under circle geometry. So I'm going to start with the first theorem. I'll be starting with the first theorem, theorem 1. Then we'll solve example. We'll take about 2 or more examples on this theorem 1. That theorem says that a straight line drawn from the center of a circle, a straight line drawn from the center of a circle, a straight line drawn from the center of a circle to bisect a chord which is not a diameter, is at right angle, to the chord. This is the first theorem that we're going to consider. That is, what is the implication of this theorem? We are going to see now. That is, if you have this is a circle and this is a chord, if this is the center of the circle, a straight line drawn from this center of the circle to bisect, this straight line bisect the chord into two equal halves. That is, if the chord is 6, let's say the length of the chord is 6, a straight line drawn from the center of the circle will divide this into 3, 3. So a straight line drawn from the center of the circle bisect the chord into two equal halves and makes an angle 90 in this right angle, which is not a diameter, is at right angle. This right angle simply means perpendicularity, this sign. This angle 90 with this chord. Of course, if this is the center of the circle, a line from the center of the circle to any part of the circumference is called radius. So if you know the radius, you are given the value from the center to the chord, let's say x, you should be able to calculate this other one, or the length of the chord, using Pythagoras theorem, because that's what we have on the board. This triangle is called a right angle triangle. This triangle inscribed in this circle is called a right angle triangle. So when we have a right angle triangle, we can actually go ahead and use Pythagoras theorem. So I want us to take two examples under theorem 1. The theorem says that a straight line drawn from the center of a circle to bisect a chord, which is not a diameter, is at right angle to the chord. Because if that chord is about the diameter, then we have a semicircle. So there's another theorem on how to approach that. So let's take example. Let's take example 1. The first example. Example 1. Let's take the first example. It says that the radius of a circle is 10 centimeters. The length of a chord, of the circle is 16 centimeters. The question now says calculate the distance. Calculate the distance of the chord. The distance of the chord from the center of the circle. Okay, let's solve this solution. So this is we can just sketch the diagram. This is a circle. Let's assume this is a chord. Then this is the center of the circle. There's a straight line from there. The question says that the radius of the circle is 10 centimeters. A line from the center to any part of the circle, that is radius. This is 10 centimeters. Then, of course, by that theorem, we know that a line drawn from the center to the chord bisect the chord. It makes angle 90 with the chord. So we are on the safer side. So, and the length of the chord is 16. So if the whole length is 16, that simply means that this line from the center will divide the chord into 2. So here will be 8. The other place will be 8. So we want to calculate we have to calculate the distance of the chord from the center. That is from center to this point. So we can just do name ceremony AB. So we want to calculate distance OB. That's what we want to calculate. So let's call it X. Then we just say consider triangle AOB. So that AO squared is equal to AB squared plus OB squared. Pythagoras theorem. AO squared, that is 10 squared, is equal to 8 squared plus S squared. Then we have 100 is equal to 64 plus S squared. So we now collect the like terms. In that case, from there now, we can say that 100 minus 64 is equal to S squared. So that S squared is equal to 36. When we take the square root of both sides, X is equal to square root of 36, then X is equal to 6. So the distance of the chord from the center of the circle is 6 centimeters, as we have it on the board. So if you have this type of problem, you go ahead and apply the first theorem that says that a line drawn from the center of the circle to a chord, divide the chord into 3 equal halves, and makes angle 90 with that chord at that point. So that is that about example 1. So let's take another example. Let's take another example before we move to theorem 2. Let's take another example. Let's say example 2. Let's take another example. Okay, in this case now, we have a chord. We have a chord of length 24 centimeters. A chord of length 24 centimeter is 13 centimeter from the center of the circle. So the question now says calculate the radius. Calculate the radius of the circle. Still the same thing. We go ahead and apply the first theorem. So what is the first theorem? It says that a line drawn from the center of the circle to a chord, divide the chord into 3 equal halves and makes angle 90 at that point. So in this case now, let's sketch a chord and the center from the chord. Let's say this is 0. A chord of length 24. So if the length of the whole length of this chord is 24, then this line divide the chord into 2. So it becomes 12, 12. Okay. The length of a chord of length 24 is 13 centimeters from the center. So from this point now to the chord is 13 centimeters. This is 12 centimeters. So the question says we should find the radius of the chord. Of course, this is the radius R. Of course, this we know that this is perpendicular because it makes an angle. You divide the chord into 2 and it's a right angle at that point. So we just say we apply Pythagoras theorem. We can say AO squared is equal to AB squared plus OB squared. Pythagoras theorem. AO squared is the radius we are looking for. AB squared is 12 centimeter plus OB squared, that is 13 squared. So we have 144 plus 169. Then at the end of the day, 9, this is 3, this is 1, and that's 313. So when we take the square root of 313, so let's take the square root of 313. So what would that give us? So that's going to give us 17 this will give us 17.69 centimeters. So that's what we are going to get. So the radius of the circle is 17.6 centimeters. Then we take the last example under this. Let's take this the last example, example 3. Let's take the last example, example 3. Then we introduce the second theorem. So let's take the last example under this and go ahead and introduce the last theorem, the second theorem. So let's take another example. Okay, example 3, where we have two parallel chords lie on opposite sides of the center of a circle of radius 13 centimeters. Their lengths are 10 centimeters and 24 centimeters. The question now says that we should what is the distance? What is the distance between the chords. That's what we want to find. So in this case now, we have to be very careful and interpret the question correctly. So here we have a circle, and this is the center of the circle. So there are two parallel chords. Let's say this is one chord, and this is another one. There are two parallel chords lie on opposite side of the circle of radius. The radius of the circle is 13. We are sure that that's 13. And the length of the circle are 10 and 24 respectively. So the first circle, let's say this is the first circle with 10. This line from the center will divide that 10 to 5, 5. Okay. Then the second one is 24. The line from the center will divide that chord to 12, 12. Because the total length is 24 and the other one is 10. So the question says, what is the distance between them? So we want to find the distance. Let's say the distance of the center to the first one is x, and the second one is y. So we want to find x and y. Of course, the radius is 13. So how do we get the distance between them? So just say the distance between them is x plus y. So if we're able to get the value of x and y, we'll be able to do that. So let's see what we do here. In this case now, let's say this is the center. Let me call this place A, B, then let's say C, D. So I will now say consider triangle COD, that is the upper triangle here. So I know that 13 squared is equal to s squared plus 5 squared. So 169 is equal to s squared plus 25. 169 is minus 25 is equal to s squared. So that's 144 square root is equal to x. So x is equal to 12. So x is equal to 12 centimeters. So I've been able to get the distance from the center to the first chord. So I'll go ahead and consider the second triangle. Consider triangle AOB. In case of triangle AOB now, that is the triangle below. So I will say in this case now, the hypotenuse is still 13. I have 13 squared to be equal to y squared plus 12 squared. Pythagoras theorem. In this case, also Pythagoras theorem that I apply. I have 169 to be equal to y squared plus 144. The 169 minus 144 is equal to y squared. So y squared is equal to, that's 25. So y is equal to 5 centimeters. So we now go back to the question. The question says that what is the distance between the chords? And of course, we have assumed the distance between the chords to be x plus y. That is x plus y as we have it in the diagram. So that will be 12 plus 5, and that will be 17 centimeters. So the distance between the two chords is 17 centimeters. So it's 17 centimeters. So I would love to stop here because of our time. So in our next class, I'm going to take the second theorem. I will take the second theorem, but I want us to note that under circle geometry, we have been able to establish the first theorem, which says that a line drawn from the center of a circle to a chord divides the chord into 3 equal halves, into 2, and makes an angle 90 at that point. And that is what we have applied. We applied the theorem to be able to solve the 3 examples that we have. Thank you, and God bless you all.